Hello 108 students, Mr. McHugh back here with you. We're going to finish up page 4 of section 5.3, and objective 6 is going to ask us to take a look at graphing polynomial functions. Now here's the good news. You've already been graphing some of these functions. Y equals mx plus b. Y equals the slope times the x variable plus the y-intercept. Y-intercept. Instead of y, we write f of x to replace it, and you've already done some of these. Now, I just wanted to take a moment here to graph f of x equals x, or y equals x. It looks at that one, and sometimes that throws students off. And if you do an xy expanded table, in this case you almost don't even need that because it's whatever value you have for x, you're going to mirror it and have it for y. So if you pick -2, the output is -2. If you pick 0 for x, you get y as 0. Pick 2, you get +2. And if you graph these guys, you see they form a line that goes right through quadrants 1 and 3, kind of like at a 45-degree angle right down. Okay, I just wanted to show that one to you. Another one here, they have example 7a. They say, what would you do if you graph f of x equals 2y? Don't forget, you could say y equals 2x. You could take the time to write an expanded xy table, or you could turn around and say y equals 2x plus 0. Slope equals what, class? 2 over 1. What's the y-intercept? 0. Come over here, y-intercept is at 0. Go up 2 over 1. Up 2 over 1. Notice if you do an expanded xy table, you'll get points that also lie on the graph. Okay, 2, 4. Okay, now the example 7b here. These are called parent functions. We've been working here. Y equals x, y equals x squared, and y equals x to the third. Notice what happens. What's the difference between each of these? Oh, excuse me again. Sorry. I keep hitting the scroll bar on my mouse, and all I want to do is just go up here. Y equals x is to the first power. Y equals x squared is to the second. Y equals y to the third is to the third. So the exponent is what I'm trying to get everybody to look at. Okay, these are called the parents because these are the basic ones that start off the rest of the graphs associated with them. So the squaring function refers to, let's go back here to b, let's focus here. Squaring function refers to the exponent being a 2, and what happens when you have x equals -2, you square it, the output is a +4. Look what happens if you put a +2 in. Any number squared always results in a positive answer. So look at the -2, 4, 2, 4. It's a mistake right there, sorry. Okay, now what happens if you put a 0 in? 0 squared is 0. So if you start graphing these, you start up here at -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Could you keep going here at 3? 3 squared is what, 9? I'd have to go up here approximately. Maybe about, I don't know, guessing just about right here. And you can see how quickly it's going up. Okay, now that's the idea. What I want to do is try something a little different here. Let me go to my toolbar. Let me pick a different color. Let's go to green here for a second. What if I said y equals, or f of x, doesn't matter, is equals x squared plus 2. If you turn around and did an expanded xy table and put values in, you'll find out that you're going to move the whole parent graph up 2 units. And you're going to graph. I'm just trying to show you the shortcuts here. We're going to be doing more of these in chapter 9. Okay. What if I asked you to graph y equals x squared minus 2? The parent graph is going to get shifted 2 units down, and the whole parent graph is going to go like this. My graphs are a little shaky looking there. Okay, now you also could have a case of y, sorry, I want to change my pen. Oh, let's use pink. Hopefully that'll catch up. Y equals -x squared. Now I don't have time here in the video to plug in the expanded xy values and watch this and expand these, but try a couple of them. What you'll find out is the parent graph is going to be flipped over on top of itself, and go down like this, approximately. And that's because of the negative coefficient in front of the x squared will make the whole parent graph flip from opening up to opening down. Okay, just wanted to show that to you here. Okay, so what if I would go back to green mode and take a graph that's well, here, let's go back to red. Let's look on example C here real quick. Y equals x cubed. Now, take the time to put these values in. A negative times a negative times a negative turns out to be a negative 8. So it's negative 2, comma negative 8, which would be about right here. Look what happens if you put a positive 2 in. Positive 2 squared or cubed equals 8. 2 comma 8 is right here. Put a 0, 0 cubed is 0, and you go right through the origin. You put a negative 1 in, the output's going to be negative 1. Put a positive 1 in, the output will be a positive 1. Okay, this forms what I call a propeller. Interesting shape when you do cubing functions. Okay, and same idea as up here in squaring functions here. You're going to get a few problems if you would be asked to do y, and again, y can be replaced with f of x, but I'm used to just saying y equals x cubed minus 2. Everything would shift 2 units down, and it would look like this. Propeller would be like this. If I would pick y equals x cubed plus 2, the whole propeller moves up 2 units, and it would go something approximately like that. Okay, so my math lab, I think here they're going to ask you just pick multiple choice answers here. When we get to chapter 9, we'll be doing more graphing of squaring functions. And we do a little bit of cubing in this course, but not a whole lot. You'll see more of it in 143. Okay, Mr. McHugh here, going to sign off here for section 5.3, page 4. We've completed 5.3, so when I see you again, we'll be starting 5.4. Okay, take care. Bye.